All right, Peter, all yours.
Okay, so let's get into our little second episode of the designer interface and some of the yummy things that we can do. In this lesson, what we're basically going to do is we're going to look at the structure tree, which is kind of the engine of the whole way that ArtMatic does what it does. And what I intend to do is to go through the whole list of things that we can actually use to build our structure tree. Now, I did what I did there was what I did last week, which I showed you, which is to click on Control and click on the active tile. Just got one tile in the system at the moment. When you click on Control, it'll give you a little pop-down window where you can select all of the available systems or components that ArtMatic has. And we define these components by the numbers of inputs and outputs that they have. So from 1 input to 1 output to 4 inputs and 4 outputs. And these components obviously go together in particular ways according to those inputs and outputs. One thing I'll just draw your attention to is that some of them have got colors on their outputs. And that signifies that they are outputting some RGB information, that's color RGB information. Also on some of their inputs, you'll have the same kind of thing. It doesn't necessarily follow, though, I should point this out right now, that RGB is only available to those kinds of components. Sometimes RGB can be used in components like the 3 and 3 out component here. It's basically just a question of the maths, but we'll get into that in a little bit. So what I'm going to do is I'm just going to start off with the very first of the tiles that we have available, and this is a 1 input and a 1 output tile. Now, I'll say right from the beginning, I'm not like a maths whiz, so I'm not going to go into the whole of the maths of what happens in every one of these little tiles. I understand some of the maths. I don't understand all of the maths by any means, but I do have an understanding, a general understanding of what these tiles do, just from using them a lot, basically. And I do understand the maths a little bit. These first 1 in, 1 out tiles, these components, are what we call scalar components. Most of the scalar components have a number of uses. And now what I'm going to do is I'm just going to click on this. When I click on this, you will see all of the available 1 input, 1 output components that you can pop into that slot. And you merely click on them and they will be replaced with the actual component that you wish to have. But what I'm going to draw your attention to is a few little useful things about looking at this particular window, and that is the way these things are grouped. You'll see that they're grouped in sort of little bunches, and those little bunches actually are useful things to know because they signify something different about each of the groups of tiles. The 1 in, 1 output components are actually, mostly they're filters or modulators. So if you know anything about programming analog audio synthesizers, which is where I come from, this concept is not really that alien, you know, the idea that you can filter things or that you can modulate things. So we have a group of things that can loosely be called filters, and they all kind of live down here. The set constant, the math tools are a bit different from that, but most of these things are kind of filtering things. Over here, we have some things which could be called modulators, and they're a different kind of modulator, or they're more a kind of a shaping thing. And these are noises here, so we've got a bunch of noises. They're also modulators of some kind or other. This little group here does a variety of different things, and they fall outside the areas of being modulators or filters, and they do various other kinds of things. And the first 3 of these are derivative functions, and these can be very, very useful for doing certain things in the ArtMatic landscape, notably taking the gradient of something that you're looking at, adding a derivative to it, and therefore giving you a sort of a fake 3D effect, if you like. They're finding the derivative of the slope and allowing you to visualize that. And then we have a few more esoteric things living underneath it. The most commonly used one of these ones will be iterations, which allow you to to talk to the system that you have here and send a number of iterations through the system. This is what we call looping in ArtMatic. It's a kind of a feedback idea. And lastly, at the bottom here, we have some memory functions, and they work in conjunction with the iterations. If you feed information through your system, you have to remember that you've done that. And so these memory functions allow you to do that. And then there's a packing component. We'll talk about those more in a little bit, but not just right here. So that's all I'm going to talk about at this stage with these things. I'm not going to look at them in any great detail other than to say, this is the kinds of things that we're looking at. One thing that I'll remind you of is that when we're sitting in a system, in a tree like this with one output, as you remember from last week, this means that we are in a tree that will actually reference the color lookup table at the top here. If it's got one output, this is what it's going to be looking at. And this is the simplest of all of the tiles, one in, one output, and it's just a gradient that goes straight across. It looks very much like the exact thing you're seeing in this gradient up here. We can, and I'll just pop in another tile there just so that you can see. We'll stick in a random one. And you'll see that now it's referring to the gradient in a random way. And this is something that can be used to modulate things in a random way. So I'm going to go into the next group of tiles now, and this one will be, oops, a one in and a two out. This is a small group of tiles that have some uses that are largely got to do with motion. There is a derivative here as well, which is useful for finding the derivative of a slope, which can give you some really lovely effects. But mostly we're looking at motion, and these motions can be used to control animation motion. Basically, that's what they're there for. You can use these to create motion that you can see in Voyager if you need to take something to Voyager, but you can also use them to define motion that happens in the animation in a flat field inside of ArtMatic itself, inside of Designer. I won't go into these in any great detail, but you can see that obviously there's a linear motion, there's a circular motion, and there's a random path motion. Very useful for that kind of thing. There's also some ways of kind of modulating things in motion. Very useful tile under certain circumstances. And a few vector functions as well. I won't go into those in any detail. So that's a very small group of components, of possibilities in that particular tile. I'm whizzing through these because what I'm hoping to do as we get further up the tiles, I'm hoping to show you some examples of things that you'll be able to use really quickly, so that I don't want you to come out of this whole explanation of all of the components and think, oh my God, that was just a whole lot of boring math stuff. I'm hoping that I can show you a few things as we go that you can use in your own playing with the ArtMatic systems. So I'll whiz through a lot of these things. We may talk about them again at some later stage when we're starting to build trees and you want to do a particular thing, and I'll pop some of these in and we'll talk about them in depth at that point. So I'm going to go into a 1 in 3 out function now. 3 out, as you remember, this means it puts us now into the RGB space. And if we look up in the RGB space, in the color tables up here, the very first thing you notice straight away is the color tables are not in action anymore. Because we've got 3 outputs, we've immediately jumped into our RGB space. And once again, you'll see the RGB set of preferences for looking at your main workspace here. This is the simplest of all of the RGB tiles, and it's basically a color constant tile. Use this a lot when you get into more complex systems, because it's just a very quick way to put a color onto something. The color is, you can see in the little space up here that this is just white, and we can control our color by just dropping something in there. We've just got a whole blank screen at the moment, so that's all we're going to see. It's a basic, simple, this is the color I want to output from these 3 outputs here. As I say, very useful as we get further and further into ArtMatic, because the ability to actually control the color in the RGB space is really quite fun and quite useful. Let me see what else is in here. Again, fairly simple sets of components here, not a lot of things. You'll see some color things. These are just ways of generating colors. You can call these generators if you like. As always, when you drop in a component here, the things that you can control are here on the parameter bar. So if we just push this along here, we're seeing the color variances. And the saturation, this is not overly saturated anyway. And the luminance, which is the brightness. So these two color generators. We can also do a few other kind of tricky things here, and that is to take the main gradient and turn it into an RGB stream. So what this is doing, you remember I said to you, we're in RGB here, so we're actually looking at RGB space. But what it's doing is saying, I want to take my input from the color lookup tables and turn them into an RGB stream. So now when I change the color lookup table, we will actually see a change in this 3 output tile. It's actually reflecting what we have in here and turning it into RGB. That can be an incredibly useful way of doing things, particularly when you come to building fractals, because it can take the gradient of a fractal and turn it into an RGB stream, which is really quite a cool thing to be able to do. You'll see that in many of Eric's fractal systems, he'll use tricks like this. And there's some more motion capabilities here too. This is putting in another kind of motion. Because we've got 3 outputs, this allows us to put our motion into 3 axes rather than just 2, which comes into play when we're talking about using things with Voyager, because now we can actually control our motion in 3 different axes, which means we can move something in the full 3D space backwards and forwards or up and down wherever we want it to be. and again, the same kinds of possibilities. We can move things in a linear fashion, we can make them random, or we can make them in a circular fashion as well. We have this a lovely tile, which is the 3D derivative tile too, which takes the derivative of a slope and turns it into 3 independent derivatives, which you can use to make a very kind of faux lighting effect of 3 different light sources. That's a really lovely little trick as well. And it also serves as a generator as well, this tile, so we can make a basic generated object, which is in this case a neon line and a half plane. These colors again are controlled by the color coordinates down here. No, that's the color cycle and the saturation, of course. Saturation did a weird thing there. I'm not sure that's supposed to happen. Yeah, that's all right. So again, a few different kinds of functions in this particular tile. They're grouped again into the sorts of areas that you might like them to be. There's one noise generator here, which is just generating a colorful noise, but only one in these 3 outputs. I won't go any further into that. I'm just going to keep on going through these. So you know, we'll just kind of really quickly run through these things because there's just so many of them. So 1 in 4 out, you'll see straight away when looking at this, it's almost exactly the same as 1 in 3 out. So what's different about it? Well, there are a few extra functions that you can grab, but the main difference that it has is that it's running a 4th output. And whenever you see a 4th output in Designer, a lot of the time that 4th output is going to be telling you that there's an alpha channel. And an alpha channel is signified in Designer by this kind of checkerboard pattern. And an alpha channel means that you can drop something else, another image into that alpha channel. It's basically what we would call transparency. I'm sure if you've worked with image applications, you'll be familiar with this concept that you can have a full opaque area and you can have a transparent area. And then in ArtMatic, we can do a gradation between those 2 things. So if we were to put another image in here, we would see a gradation go through from full white into that image. So, you know, the basic same kinds of things. We can pull in a main gradient into that area. We've got an alpha channel still with that. We can have a straight RGB gamma, which allows us to change the gamma of the color. And a few kind of tricky things like some generators, and again with some alpha channel in them. So there's the ability to put them in front of other images or other parts of the ArtMatic system. So that's kind of our one-in, that's running through the gamut of our one-in components. Scalar functions with various kinds of outputs. That's all you need to know for the moment. Now we're going to start with the two-in, one-out components. One thing I should tell you is that the way that we work with an ArtMatic tree is, I'm just going to put in some extra components. The data flows through the tree from the top of the tree all the way through to the bottom of the tree. So your math functions are being calculated as you drop down the tree. You can have tiles that kind of come off to the side, and these will kind of split the math function into two parts. So you can actually be running two separate math functions or two streams of math functions, and they'll be calculated at the same time. But nevertheless, they're going down the tree and they will come out at the bottom of the tree. One thing that has to happen to have a fully meaningful ArtMatic designer tree is the tree has to be terminated. When you have something happening like this, where you've got a little side shoot like this, this side shoot's not actually doing anything until we terminate the tree, because the maths is kind of not, it's like a tap that's kind of running off and being closed here. It's not going anywhere. So we have to bring it somewhere down to the bottom. ArtMatic will allow you to actually automatically terminate a tree. And what it's done in this particular case, it's actually used this little tile here as a mixer, and it's terminated these two trees to give it something meaningful. It's kind of a bit weird at the moment because it's actually superimposed one function exactly the same over another function. So let's just put something else in there. And you'll see that now we have this Gaussian circle has now been superimposed with this very simple component to make this sort of bump. It's basically, if I took this one out, we'd find that there was just a full circle in there. I'm not going to get into that too much. I just wanted to just show you how the data flows down the tree, because that's an important thing to understand with ArtMatic. So the one output functions, they can be used as mixers. So there are a number of different kinds of components inside of ArtMatic in the way that they function that are kind of generally true over different areas. And one of them is mixers. So a two-in, one-out component can act as a mixer. And the way that that would happen is that if you were taking a stream of two of these things, two outputs of some kind, you can mix them together with this component. So let me just show you very roughly what that is, because I'm going to just put two. So I'm just adding branch components here. So basically what these are is I'm checking this tile and I'm using this function to make a branch off to the side. I'm hitting the B key because that's the way you do it with key commands. It's a simple way of doing it. So if you have a function selected, a component selected, and you hit the B key, you'll get this little side channel there. Now what I can do here is I can connect these two together using this one as a mixer. This won't make a lot of sense off the start. Oh, and to do this thing automatically, what I've just done there is I'm holding down, so this is the active tile, and if I hold down the command key, it'll make an automatic connection to this tile. It doesn't always do it in the most sensible way, but sometimes it will try its best to do the most sensible connection. But you can also manually do it, and the way that you would do it manually is to click on the tile to select it, and now Option Command click on another tile, the one you want to connect to, and we can actually now just connect these two, that output into that input. And when I let go of it, we're now connected. So both of these two components are now being mixed together by this component. This doesn't make a lot of sense in this case because we have these components generating exactly the same things as the mixer is handling. So let's have a look at one of the other functions of the 2-in and the 1-out, and that is the shape generators. So we can actually generate all kinds of really cool shapes. And you'll see these things are all grouped together. These are the generation side of things here. Over here is the mixing side of things. So this component can act as a mixer or a generator. And there's some more generators here and some other things here, which we'll talk about in a sec. So I'm going to just select a couple of things here from the generators to mix together. And you can see now the function of this 2-in and 1-out is doing all the things, or many of the things that it can do. It's generating a shape here, it's generating a shape here, and it's mixing those two shapes together using this algorithm. So if I choose a different kind of mixing algorithm, let's say the distance one, you'll see that it changes the look of it. It's because the maths of this one is slightly different, and it's actually mixing the two streams of coming from these two in a different way. So mixer, generators. I also noticed when I was looking through this that these things here are actual generators too. This probably should be more properly put over here because they are actually generating something like a dot in this particular case, or a profile shape in this particular case, which is in here a triangle. Another thing that I did mention very briefly last week, but I'll mention again, is that when you see a description here which has a hash mark after it, that hash mark means that there are a group of things here that you can select. It signifies that this particular tile, when it's been selected here, has some extra functions that you can select down here. In this case, we've just got a whole bunch of different kinds of shapes that we can drop in there to get different kinds of effects. And as usual, those things, the parameters down here control aspects of those shapes. In that case, the radius and the width and the height. But again, being mixed together by this function here, and because again, it's a 1 output tile, it's looking at the color lookup table, which means that if we pop something in there, that will change the look of that. So 2-in, 1-out, shape generator, mixer. It has a couple of other functions as well. It can generate noises. So over here we have a group of noise functions, and down underneath it some more precise noise functions, and then some more specific noise functions there. So that's what the 2-in, 1-out does. This is a great starting point to start building systems when you want to make something very simple. So last week, as you may remember, I kept going back to our circle here. This is just a great simple system to start with because it's easy. You know, you can see that this is a circle. You can change the tables here to have a different kind of profile on the circle, and if you feel like it, change some of the color patterns here to see how that maps across to this particular circle. It's a good way of just getting a feel for how the gradient is being affected by the color lookup table. Now, there is another function that the 2-in, 1-out serves, which you might use a fair bit, and that is to use it to drop in an image. So this is actually just a black and white image because it only has 1 output. So it's not outputting anything to the RGB stream. It's not a full color image. Instead, what's happening is that the color is being mapped to the color lookup table, as we know will happen if it's got 1 output. To see it in full black and white, we would just do that. That's just a gradient scale from black to white, and that's what it looks like as a black and white image. As with all of the images and the way of manipulating images inside of Designer, you have a few things here that control various things. One of them is the tiling, and that just means how many iterations of the image you see. If we zoom out of our canvas here, you'll see that there's lots and lots of tiles going on there. As usual, want to get back to home, we just switch the home button. But we can also stop the tiling from happening or change how the tile varies by pulling the control right to the left, which means it's only tiling once. So if we zoom all the way out, we only have one iteration of that image. I shouldn't use the word iteration, actually. That's not the right word to use here because it's not iterating anything. It's just mirroring or tiling the image. You also have a blurred picked version here, which allows you to pop in an image and blur it. Now this is great for just blurring an image, but it has some really useful functions when we get to using certain kinds of tricks in Voyager, where we can actually use height maps, and you may want to kind of blur the height maps a little bit so you don't get as many little jaggies on them. So it's quite a useful tile to keep in the back of your mind. And we have a symmetrical one as well, which basically takes the tile and then makes a symmetrical version on either side of it. That can be fun for various kinds of things. There are other ways of doing symmetry too that we would use, possibly not in this particular case, but if you want to use symmetries, we'll look at those in a little bit. The orbit analyzers, I'm not absolutely sure what they do. There's something to do with fractals, and I know that Eric uses them a fair bit. I'm not going to even try and explain them because I don't understand them. Let's go into the next class of 2 in and 2 outs, and this is the space transforms. Now these are great tiles. You'll find yourself, if you're working in Designer alone, you'll use the space transforms quite a lot because as you remember from last week, we're looking straight down on a Cartesian plane. So we're basically looking kind of at the X and the Y axis. And this is reflected by the ins and the outs of this particular component. It's actually putting in the X-axis and the Y-axis, and then it's putting out the X-axis and the Y-axis. And a space transform means that we can actually transform the space that's coming through this component. Now, to show you how that works in a really simple way, I'm just going to add another component to the bottom here, and we're going to go back to my favorite little Gaussian dot circle. Now, let's just examine the ways we can transform space here. We've got lots and lots of ways of doing it. Math tools have popped up in a lot of these little categories that we've been looking at, and the math tools allow you to directly influence the math of the space in various ways. I'm not going to explain any of those at the moment. The simplest of the space transforms is just an offset. So it is really quite easy to see how this one works. Let's just make the size of our circle, oopsie, here a little smaller. So this is the simplest of the space transforms, and it's reflected in the 3 variations that you can do here. One of them is scale, that is the scale of the object. So I can change the scale to smaller or larger just by dragging that slider or hitting in a numerical value. Don't forget that we actually can type in values here. That becomes very, very useful actually as you get further on into using Designer, where you'll find that you want to be more precise. Some things, particularly in fractals, the balance between what looks fantastic and what looks really ugly is just a few points of difference. It's tiny, tiny little increments, and using the sliders to drag can just be completely useless for that purpose. So being able to enter data into there is very, very useful in that respect. And then we have an offset for the x-axis, which just does what it says. If I drag this along here, we're offsetting our Gaussian dot from the XY axis. So whilst we're still right at home, we're looking at the middle of the X and the Y axis there, we've now offset our Gaussian dot from the middle of that X and Y. We've offset it on the X axis. And we can also obviously offset it on the Y axis. So This is transforming the space of what we're looking at. It's transforming the space in a very simple way because we're just offsetting. That's all we're doing. But we can have much more complex space transforms as well. Now, you will remember here, if I click on this function and go down to reset all to default, it'll turn all our parameter settings right back to default, which will put our circle right back into the center of the frame. So I'm going to show you some of the other space transforms. Rotate just does exactly what it says. It rotates. Will have no effect at all, of course, because this is a circle. So let's put in something different. Let's look at a profile shape. So we've got a triangle there. And I'm just going to go back to this and rotate the triangle. So once again, just transforming the space that we're looking at. We can also offset the center of that rotation and rotate around the center in a different way. Very simple component, but again, a very, very useful component to remember this one here. Skew function, which just skews the pixels. And then we get into some of the more complicated functions. I'm not going to talk about things like the edge logic functions at this stage. What I'll show you is just something like the mirrors. So here, this is a mirror tile function, and it's just mirroring the space that we're in and tiling it. There are quite a few mirror tile functions in Designer. This one is possibly the simplest of all of them. Or maybe actually this one is probably the most simple of all of them. It's, I need to make this a little smaller. Oopsie, let's go down here. Oh, I can offset them in here, I think, in the scale. Wrong way. So that's a very simple function. It's really just taking a shape and repeating it many, many, many times. So we have some much more complex functions that we can choose from. These kinds of things here are basically doing various kinds of space transforms. Nice effects available here. Some of them are fractal effects. And then the mirrors, which are grouped together at the top here. So we love the mirrors. We'll briefly, I'll pop in here our photograph again. This is one of the things that people find very, very, a lot of fun to work with in ArtMatic, and that is to use the mirror tiles, the kaleidoscopic effects on images. So you can take your image and you can commit various kinds of symmetries to it, create lovely psychedelic and kaleidoscopic effects. If we map a color to this, you'll see that you can get some really cool things happening straight away. There are a few different kinds of mirrors. Best way to figure out what they do is just to play with them, really. I don't really need to go through and tell you what each of these does because they're all much more obvious if you play with them, and we don't want to do that at the moment because it'll take too much time. And we'll drop down to the next group underneath the mirrors here. These are a different kind of mirroring, but down under here we've got some complex functions. And the complex functions map various kinds of math complexities to whatever is underneath here, remembering again that the data flows down the tree. So if we have this at the top of the tree, it's going to affect what's underneath us here. So let's just look at another one of those complex waves, let's say. You can see that it's changing the image in a complex way because this is a complex maths function. And then we've got some various other things here to do with, space distortions that you can do. Then we have up on this side, we've got some noises. And the noises, again, are very, very useful functions to kind of get your head around, particularly these space transformation noises. And you use them quite a lot. I use them a lot to try and give some level of randomness or unevenness to things. You'll find that when you're getting into making objects and things and trying to give them a little bit more of an organic feel, it's really good to have a noise in there somewhere to kind of give some distortion that doesn't have that kind of very regimented mathematical feel to it. A random noise here, which is, you know, very highly effective on this. One thing I'll tell you is that we'll look here at the noise amplitude, and the amplitude tells you how much of the noise is being applied. So if you drag your amplitude down, it gets less and less and less, and you'll see that you get closer and closer to the original image that we had in there. And that original amplitude, or let's just set it to 0, and you'll see it has no effect whatsoever. Just taking up a tiny bit gives it a much bigger effect, and the phase and the frequency of the noise. These things you'll see all the way through ArtMatic. So whilst you're when you're using Designer and you're actually working on images, you'll come across these noises, and you'll see this amplitude, phase, and frequency quite a lot. This is the frequency of the noise. That is how much, what the wavelength of the noise is. So if you make it really, really big, you'll get like lots and lots of noise. And you take it into very long wavelengths of noise, it has a much gentler effect on the image. And the phase, which is where the actual phase of the noise applies. It doesn't change the frequency, just where you apply the phase of it. And the amplitude, as I said, how much it will do that. We'll go into those when we start to kind of build some trees, which is one of the things that I think we'll get onto next week. I'll show you some simple ways to get some great effects happening. And we'll use some noises, because the noises are absolutely fantastic for doing that kind of stuff. There's a selection of noises, and when we talk about noise, it has kind of different flavors, if you like. So that one that I'm using there is what we call a random noise. It's very different to a low frequency noise. You can immediately see that the wavelength, the frequency of the noise is actually quite a lot longer. So it doesn't have such a big effect on not as squidgy as the high frequency noises. We have a Purlin noise, which is a different kind of noise again. So they all have different sorts of flavors. And when we drop down into the next little group here, we'll see these are noises that are much more complex. And they have a lot of use for building things like textures. And when we get into doing Voyager, into the way that kind of landscape textures work. Some of them, like chaos displace, for instance, these are getting to be the kinds of noises you'd expect to see in landscapes. Kind of quite irregular, and they have a certain look about them that makes them look more like something you might see in a landscape. One thing I'll point out here too is another thing that you'll see in a number of ArtMatic systems, and that is in components, as a matter of fact, is this time thing. What does time mean? So time is something that comes into play when we're using a moving ArtMatic system, like an animation. And when we have a time component active, what's actually happening is, let me just, without us create, what I did then was I just created 2 keyframes. They're basically the same keyframe. But what I'm hoping to show you here, I'm just making more of the time side of things. So, as you remember, I told you last week that when we lock our components here, this stops them from changing any of the parameters. If we wanted to create an animation, we would typically put a frame in here and a frame in there, and then we would change some of the parameters on one of those frames in order that we could animate from one to the other. In this particular case, just because I'm trying to show you something, I've locked everything. So I've locked all of the parameters, so nothing can change. But when we hit play, you'll notice there is actual movement in there. Something's moving. And that's because this is a time-based component. And what's happening is that this component allows time to influence it. And so you are finding that these 2 identical keyframes are having a difference over time. So keep that in mind when you're doing animations, because this can kind of catch you out sometimes. You might think, hang on a minute, I want to animate this particular thing, but something else is animating and I can't figure out why. Just check that you don't have one of these time components in there, because they will do their work without even referencing the keyframes. So I'm going to just clear both of those again. And what else will we go down? Oh, I won't actually go into this too much more. We've got some, many of these things are best understood by just playing with them. All you need to know about this component is that it's actually transforming the space of the components underneath it. Let's drop back into our little Gaussian dot again. There you can see quite radically what's going on. In fact, let's just lock this and make two versions of that and hit play. And you can see very clearly that that's doing something with the time component. And just to make it even clearer, I'm going to pop this out with something else. So let's just use multi-Purlin displays. And I'm going to hit play and nothing happens. And we would expect that because there aren't any keyframes that are different. These two keyframes are identical and there's no time coming into this stream. I keep doing that. Oh gee, I've got to whiz through. It takes so long to get through all of these things. We may not even get halfway in this particular tutorial. So let's get rid of those ones. I've got to go on to the next lot, 2 in 3 outs. We love the 2 in 3 out components. Now, one of the things that you'll notice straight away is we've gone into RGB space. As soon as we have a 3 out component, we go into RGB, we lose our color lookup tables. Here we have a really large selection of different kinds of components. And this is a really good demonstration of how a component can have many different kinds of uses. And you'll find this quite a lot when you get into the components that have got 3 outputs and inputs, because the maths can be used to manipulate both color and shape and space. So it can have a lot of different uses. The one that comes in as a default at the top here is the 3DZ set. That's just a very simple component that allows you control of the 3 outputs here with 2 inputs coming in. So it's really a Cartesian component, but it allows you to actually control 3 individual outputs. I'm going to pop in something here to show you this group of things here are actual shape generators, and they generate kind of pseudo 3D shapes. So I'm going to pop in the 3D sphere here. You can't really see at this point that it's a sphere because it's kind of taking its RGB from somewhere which doesn't really help us to understand. So what I'm going to do is put in a component here, and I'm just going to, just for the sake of this, I'm just going to put in a fractal noise, acoustic noise component, just so that you can see that this is actually a sphere. So you can see that the caustic component has been mapped to this in such a way that it allows you to see that there's distortion and it tells you that it's a sphere as opposed to just a dot. And if I go through some of these other components here, you'll see the same. And that's called an ellipsoid, but it doesn't have any ellipse thing because I have to move the component there, the parameter there. And we can look at a cube. Looks like a square, but by manipulating its rotation, which you can do here, you can see that it actually is a cube. There's one thing that doesn't come into play here is that there's no kind of lighting effect on this at all, because it is not a real 3D object. It's just a mathematically produced version of a 3D object on a 2D plane. So there's no actual lighting, but you can see how the distortion of the texture allows you to see that it is in fact a cube. And we have various other things here. You can play with all of those things as well. The other main function here, though, let me just get rid of this and we'll pop back into, oh, another thing you can actually do here is, as we saw in the 1 in 3 out components, you can actually take the RGB, take the color lookup table and map it into an RGB space with these tiles as well. So that has some uses that we may go into in a little bit. This can also generate a variety of different kinds of color spaces. And these are all kind of self-explanatory. Thing to remember is that they are three outputs. So once again, we're in a full RGB space. I'm just going to clear out my... and then there are some noises over here. These just generate, they're basically generating some color noises. These are really useful for putting noises in, you know, just kind of random noises into systems. Really quite lovely. And there's this little area here, which I'm going to talk about in a second. And these, you're going to start seeing these as we get further and further through the components. You're going to see this packed thing, what these components call packed things. But first, I'm just going to show you the RGB picture. So this is exactly the same as we saw with the other tile, the 2-in 1-out tile, where we put a picture in, except now you can see this is full red, green, blue. We're in full color here. This is a color picture, but in the other version, when I put it into the black and white tile, into the 2-in 1-out tile, its color was being modulated by the color lookup table. It was actually only putting out a monochrome signal. Here it's putting out 3 individual streams of red, green, and blue. One of the things that's very powerful to be able to do in Designer is to use it as a color mixer, and there are many ways of doing that. So you put a component after it. This is a 3-in 3-out component, which we'll get to in a little bit. But it's putting out basically maths. It's taking the output of this and putting out the maths of scale on these 3 outputs. And in this particular case, the mathematics is going to map to the scale mathematics is going to map to the RGB values. And so by changing the values, we change the color. So that is that's a simple way of changing the color. I won't go into those because we need to fully go through this one first. I'm just going to pop down here. This allows you to put in a picture over a shaded color background. Certain uses for doing that. It's a quick way of doing it. There are other ways you could do that as well. And what else can I talk about there? And that's probably enough to talk about with the pictures just for the moment. Tiling and everything, of course, in these picture tiles are controlled from here, just as they are in the 2-to-1. What else? Oh, and to put in an image here, in fact, I should talk about that. This tile comes up whenever we select an image tile. You'll see that's disappeared. But when we select an image tile here, so this component has now become an image component, and we now have a menu which allows us to choose what image we wish to have in there. So I would just do that by opening an image. When there is no image selected, it will obviously just go to the default UNI software logo, which is the default image. Otherwise, it will select the image that you wish to have in there. Yeah, generators. What else was I going to talk about? The loopers. So this is a function called a looper function. These are functions, and again, I don't want to get into this because it's a very complicated little area, but just very briefly, this allows you to take the system and feed it back into itself. And this is a really great way of creating very complex objects. So you can take an object, you can have it do something like rotate in space, and then you can change its rotation over iterations so that it can change its position in space and it can change its place in space, and you can just repeat it. It's like a feedback system. When I get to building some trees, which I think we'll make our next lesson, I'll show you how we can make a simple iterated system, and you'll start to see the power of iteration. It's one of those things that can be fascinatingly rabbit hole-like. When you start playing with iterations, you'll find you want to keep on doing it because there's so much power in there. And you can iterate most of the things that are available in the tree. But as I said, quite complex, so I'm not going to go into explaining it right now. I will spend some time, though, explaining these kinds of components. These are what we call the packed components. Now, these are mixing components, and they allow us to mix one component or two components or more into another component. Now, to do this, I have to actually just build some tiles for you, so just bear with me while I do this. I'm just going to make a couple of image tiles. I'm going to just put some pictures in here. Get rid of that for the moment. So what we have here, stick that in there. What we have here is a couple of pictures. They're not terminated. They aren't going anywhere. You'll see, as always in a designer tree, the leftmost component in the tree, if it's not terminated, will be the one that you're looking at. What I'm going to do here is I'm just going to put the, this should mean, I can't do that there. There are two, hopefully there are two different images in here now. One of them will be the default image and one of them will be the statue. So I'm going to show you how we would mix these two color images together. And to do that, we need to pack the color streams. So it's putting out an RGB and it's putting out an RGB, but in Designer, we have this ability just to make those outputs packed into one output, just to make them simpler. And the way we do that is we hit the P key and add a packed component. That means what it's doing is it's taking the three color outputs and packing them into one. And that's where our mixer comes into play. So now I can just hit this termination here. And it doesn't know. It's put in a mixer, but it hasn't put in a color mixer. It's put in just a scalar mixer. So it's doing exactly what you would expect it's doing here. It's taking two images, it's mixing the scalar values of them and mapping them to the color lookup table. So you can see both the UNI software logo and you can see the angel, and they've been mapped together in one stream, one scalar stream. We don't want that. We actually want three outputs so we can have an RGB stream. So again, control click on that, and I'm going to change this component to a 2 in and a 3 out. And straight away you can see that we now have our two streams of images mixed together with a mixing component. And that's what this particular component is. It's a mixer. This one is a packed RGB crossfade. So it's merely doing a very simple thing. It's taking the left-hand stream and the right-hand stream, and it's interpolating the values of each. In other words, if we put this right to the left, we see what's coming in the left-hand stream. And if we put this right to the right, it's seeing what's coming in the right-hand stream. It's literally giving them equal values of mix when it's in the middle. We have a group of different forms of mixing. And if you work in image manipulation programs like Photoshop or Affinity, you'll understand some of these terms like adding the values. So in here, it's adding the brightness values together, or using the maximum values, or using the minimum values. So it's calculating the pixel values and then adding them, mixing them together in that particular way. We also have some mathematical functions here as well. So we can use various math functions to mix things together. And one of the main ones you'll be familiar with if you use photographic applications is multiply. It's multiplying one pixel value by another. And again, if you look at the selection for this particular maths mixer, you'll see that hash mark, which means that we have various combinations of different things that we can do to add the values together or subtract them in this particular case. So that's what the packed concept is about, taking the RGB stream, packing it with one of these little components, and then allowing you to get that as one output and put it into one of these special mixers to mix things together. So that's your 2-in and your, have I gone through a lot of those? Yeah, that'll be enough for the moment. So let's go to the next lot, which is 2-ins and 4-outs. Straight away, you might think, well, that looks exactly the same. It's exactly the same as the 2-in, 3-out, but it isn't. And this is where we come to one of the fundamental things about 4-output components. They often, if you see a 4th output on one of these components, it often signifies that there's an alpha channel in play. And that is, in fact, exactly the case with this situation. You can't actually see the alpha channel in this case because there is no alpha channel in the image. But if I select something with an alpha channel, like a circle, this is again, these are generators. So this is another function of this particular tile as generators. I've just selected a color circle, and you can immediately see that 3 of the outputs go to the RGB because this is not having any effect on our color. This is being controlled inside the component itself. And then the 4th one is being mapped to the alpha channel. And that's the case with all of these generators here. They'll all map something to the alpha channel. In the case of something like this, this little dot here, this is exactly the same Gaussian disk as we have in our 2-in, our 1-out component, but in this particular case, it's got an RGB output as well, so it allows it to have some color. And it's got an alpha channel, so you can actually combine it or composite it with other things. You also have a blurred version of the image as well. One thing you should be aware of when you're, and you can see the alpha channels active here in this version as well. One thing you should be aware of when you're using the blurred component for pictures is that it does take a bit of calculation. So it can slow your systems down a little bit using that particular one. It's a lovely effect, but just be aware of that. Then we have some generators, various kinds of tiles. This is where we're getting into the tiling functions of Designer. There are many, many tiling functions, and they're actually really, really useful. Good things to play with. You'll find that so many of them in different kinds of looks. Quite a lot of them have this hash mark after them, and as you'll remember, the hash mark signifies that there are some variations you can play with here. Then we have a group of other kinds of generators here. These are all generating various kinds of effects. Once again, all really, really useful for creating patterns and designs and textures and all kinds of other things. And you can kind of see as we get into this area that we're starting to talk about some of the stuff that will be useful for working in ArtMatic Voyager, where we really want these things like rocks and pebbles and things like that. They're very useful for creating those kinds of landscapes. And they also have this, this 4th output, which aside from being useful as an alpha channel, can be used to send information to Voyager to do certain kinds of things. So it's something to keep in mind as well. Now, Caleb, I'm just going to ask a question. We're going over the hour now. Should we keep going? I think he's gone. Let's keep going. Again, there are a group of mixers here. They're very similar to the mixers that you saw in the last group, but this one is slightly different in respect of the fact that you can now mix components that have an alpha channel. So you can actually mix 2 4-output components together and maintain the alpha channel. The alpha channel can run from through the mixed components into this component and still preserve alpha at the end. So these become very useful when you want to start compositing one kind of thing over another kind of thing. The alpha channel gives you that transparency, and you can actually use that transparency to pop something else from behind. So you get quite complex systems with this sort of thing. I might just I'll make a little detour here because just to show you a few things about the complexities of the systems, because we did touch on this very briefly last week, but systems can become incredibly complex, and these mixes become very useful and very almost necessary, well, absolutely necessary when your systems become very complex. Because, for instance, you can have a situation where you have a compile tree here. So we have a tree which is talking to a tree inside it. So let's just put some other components in here. I'm not making any effort here to make things make sense. So we have one tree here. This is our main structure tree. We're at the top of the structure tree. And we have here what's called a compiled tree, which means that there is something else, more components inside this tree. And by typing the E key, we can have a look inside this tree, and we can see those components that I put in there before. So it becomes pretty apparent very, very quickly that you can have all kinds of compiled trees running here. So now I have two compiled trees here. It's not going to connect for me. Let's make this, let's go in here. I'll just make this a 2 out. I'm not explaining a lot of what I'm doing here because it just bogs down too far. So very, very rapidly, you can end up with a circumstance where you've got a lot of compiled components, things inside things. You can even have a compiled tree inside a compiled tree. So now we're 2 levels down in the compiled trees, and we can come up to that level, and then we come up to the top level. So you can actually get very complex trees. So these mixers allow us to take these components and put them together in useful ways. And as the trees become more and more complex, the necessity for the mixers to come into play becomes greater and greater and greater. And you really need that kind of control over your trees to be able to keep them compact and keep them making sense. Where will we go now? The 2 in, a 4 out, 2 in, 5 outs. So this is the last of the 2 in components. These are actually kind of, there's only a small number of these, and they have specific uses. They can control, they can actually generate something and also have a space transform in them as well. You can see straight away that a lot of fractal things start to come into play here. I personally don't do a lot of fractal stuff in the 2D world of Designer. I'm more interested in the 3D fractals. But if you examine Eric's systems, you'll find that there's a lot of these things being used to do various kinds of things in his systems as far as generating and manipulating the fractals go. Just see what else we have in here. That's pretty much what they are, all kinds of generators for those sorts of things. As I say, I don't look in that one very much, so I'm not that familiar with it. Caleb's back. Can you hear me, Caleb? Are you listening?
Yes, indeed, I'm here.
We've gone well over the hour. Shall I? It's going to take me quite a long time to get through the rest of these components, so I'm thinking maybe we should split this into a second one.
I agree. I think it was a great start in on the components and understanding some of this high level component concepts such as generators, the compilation stuff like packed components, subtrees. So I think that was a good chunk of the overall concepts and then the beginning of the different families of components. And that's a big chunk to chew on. So breaking that up into another section would be great.
I think so, because we're getting into the more complex 3 inputs, especially when we start these kinds of components where we're talking about generators for 3D objects for Voyager. So there's a whole new thing to talk about when we get to that point. So this might be a better place just to, kind of call it quits for the moment, so we don't kind of get too overwhelming. So I guess if anyone's got any questions about anything where we are at this point, this is the time to ask them.
So we've got Andy and Steve online. I can switch over to a group view.
Okay, can you hear me?
Yes.
Okay, first thing I might say is talk a bit about the order in which tiles are vertically and how they impact on each other. Like certain
Yeah.
things have to be above other things, other things have to be below other things to function properly.
Yeah. So most of the time, what we're talking about is transforming the space of the things underneath the tiles. As I said, the data kind of rolls through the system from the top to the bottom. So if you have something like an image in here, you're going to be, at this point, maybe you're occupied with putting something like a mirror in here and changing the spatial characteristics of whatever you have in your image tile. So this is controlling the space of this image tile. When we get below that image tile, so this is what we would call an object. So we would think, okay, well, this is an image. It's a kind of an object. We could have other objects in there if we so desired. We could put in one of those spheres, for instance. But let's just stick with our image for the moment. So we call this our object. Then underneath our object, because we're now in a three and three out, which is an RGB space, we might start thinking about controlling aspects of the color of our object. So one way so now we have a space transform. We might have multiple space transforms. I could, I can have a mirror there, but I can also have a noise, for instance. So I'm now running a noise. The noise is, let's just make it a bit more extreme. So the noise is actually influencing the image, but the mirror is then mirroring the noise. So this noise, well, let's just drop the mirror out. That's just noise applied to the image in the way that we saw earlier. If I change the phase, it'll kind of wobble it a bit differently. But if I put in a symmetry tile above that, of course, it's now going to make a symmetrical version of the noise modulated image. So you can see that the data is flowing down. I could put in a noise tile above the mirror, and now we can see that the noise is actually influencing the mirrored version of the noise influenced tile here. So the data is flowing down there, and this is all transforming the space of this particular object. As we drop below it, though, we can't influence the space any longer, but what we have to our ability to do now is to influence the RGB space, the color space. And so let's put in a tile that might do that. Let's say the color shift tile. So now what I'm doing is putting the RGB values through a tile, a component that's specifically designed to influence certain aspects of the color space. In this case, we can shift the hue of the color by dragging the hue back and forwards. You'll be familiar with that if you've used Photoshop, that kind of idea. And the actual lightness and darkness of the image, pixel value, lightness and darkness, and also the saturation. So we can pull it right down into full black and white if we want. We can add back up into what we had before. So that's the color space. And then from this point, of course, we may be doing other things to change. We might have another stream of image, which we are then mixing together. So let's do that. Let's just have, we'll make another image on this side. And we will just put the blank one in there. Now I'm going to combine those two streams. So what I've done is I've combined the UNI software logo with the mixing tile here. So we're influencing the color of this one, and we've mixed these two together into the stream, which gives a mixed version of both of those images together. And of course, we can keep on manipulating the color as we go down. This is one of the very powerful ways of actually combining things in Designer to give you various kinds of different effects. So that's a mixer tile there. So our mixers would typically be sitting at the bottom of our tree. Then our color tools would typically be sitting next up, and then our object, and then our space transformations. Does that give you some idea of general flow?
Yep. Yep. If you put one of the tiles in the wrong place, it just has no effect. Is that the case? Or?
No, it's not true. When we get into the 3 and 3 out tiles, we'll talk about how they can actually have different forms depending where they are. I'll show you briefly. So let's just, this tile here is basically just showing you the scale, and I can use it to manipulate the RGB values. So I've just changed, it's a scale thing, but its values will affect the RGB as well. It's just a maths tool. If I was to put this in a correct system up here, this is not really the right kind of system for doing it, but just allow me to do it to show you. So if I make this a 3 and 3 out as well. So essentially this is the same, in fact, I'll make it the same tile. It's the same tile, it's exactly the same, but you can see that it's now in a space of space transformation. So now instead of it having any effect on the color, it's now changing the spatial characteristics. So these two tiles are the same, but where they sit in the tree makes them act differently. And there are quite a number of different components which will behave like that. So getting that idea of how the information flows through the tree will help you understand that if that tile is sitting up there, it's going to act very differently to if it's sitting below a color component.
Following on from that, yeah, sorry, can you hear me?
Yes, I can.
Yeah. I've seen a few files where there seems to be a parallel top tile that's not actually connected up to the input
yes.
matrix.
Okay.
And I never quite understand what that means.
I'll show you why that is likely to happen. Let's use our image again. I always have to hunt for things, even after all this time. I still have to hunt for things in the interface. So let's just assume that we have an image. Now, this is something that would be a very common thing for you to do if you're in an image manipulation program. I'm going to create half the tree so that I can show you how this works. So I'm going to make this into a math function here. And I'm going to, it's now a multiply function. Now you would use, the trick I'm going to do here is something you might use when you're working in Photoshop. If you wanted to put an image cast on something, you wanted to actually influence, say, the blue colors on something. You wanted to make your image feel like it was a bit bluer, but you didn't want it just to be added across everything, just as a transparent layer. You wanted it to give your blueness to the blacks, in fact, and that's what you would do with a multiply function, which is what I'm doing in this case. But I'm not multiplying it with anything at the moment. I'm going to create another tile to do that. And I'm just going to run it as a branch for the moment. And I'm going to create a 1 in 3 out and put in a color constant tile here. And I'm going to pack that color constant tile so the RGB streams are packed together. And I'm going to connect it here. And I'm going to give it a color. And it's given a blue cast across. So it's basically multiplying the blue values across that image. But the input to this tile doesn't make any sense. So it doesn't matter what I put on the input of this tile, it's not going to affect it at all. So it can effectively be completely unterminated because no information is flowing in to the input of this tile. It doesn't need it. And it doesn't require it, and it won't do anything if it was. So when you see that unterminated tile at the top of the tree, it only means that it has no necessity to have information going into it to do the thing that it does. That's all it means. Sometimes if I'm building trees, one reason that you might want to terminate it, so if I terminate it to there, it has no effect. No values are going to come into this tile. But there's a really good reason for doing it sometimes. And that is if you wanted to actually do this as a complete bundle and have that tile associated with that bundle. Because if it isn't terminated, you can't actually associate it with that bundle. So I'll show you, if I try and make this into a new tree, it does not like that at all. So that might be the one reason that you would do that. And you just make, it's like a fake termination. And I often get into the habit of doing it purely for the reason that I want to keep my trees contained in that way. Well, what I'll do, it won't be next week now because we're going to go through more components, but what I will do, we'll start with some very basic ideas, you know, how do we do this particular thing? And I'll structure some trees together, and you can have a look at those trees and see if you can follow what things that we're actually doing. And we'll discuss some of those kinds of things, and it'll help you understand how to go about building a tree. So we'll start off with doing something that's very simple, and allow you to try and get your head around where we go in the steps of building a tree to do a particular thing.
I imagine also, given the fact there's a bit of overlap in tiles, you could achieve an identical effect in drastically different ways. More
Absolutely.
elegant.
There are many ways to achieve certain things, and sometimes it's not unusual for me to go down a path where I've done something and then realize that's actually a better way of doing what I've done. I've made it too complex for myself. I particularly notice that when I go back into old systems because, you know, Designer is very, very complex, and there are many things to learn, and there are also new things being added all the time. So occasionally I'll go back into an old system that I've done and I'll just go, wow, I can do that much better now. Like, there's a simpler way to do it now, or I understand something better to do, better way to do it now. But it doesn't mean that there aren't multiple ways to actually achieve certain kinds of things. What I hope by the end of this kind of exploration of Designer, what I hope to get you to be able to understand is just basic methods for going forward, so that you can kind of start going, well, if I wanted to do this, this is the best way that I could set about doing this particular thing. If I want to make, you know, I want to make a rock for Voyager, this is the way that I would start to do that. Where you go from there is obviously kind of an exploration. And if you've taken the trouble to look in Dick Scherzinger's files, you will see that his files are incredibly complex. I don't really understand many of them fully. And that's because he would have done what I would do when I'm building something, and that is he'll go down a certain path, he'll get to a certain point, and he'll realize I can do this now, and then I'll add this now, and I could tweak this now, and then if I add a noise function into there, that's going to control this now. And you just start adding these things to sort of refine the way your system is actually working, just adding little new things and polishes, and, you know, I can stick noise on the top surface of that, it'll give me a nice rough surface on there. I can put color on this side of that thing, and, you know, they become very complex very quickly. But the thing to understand is, well, two things to understand. I can look at my own systems and not understand what they're all doing without actually diving into them and kind of tracing the path. So an old system, I can look at it and I go, I have no clue what I was doing there, so I have to relearn what I did. And also that it's all about really being simple and adding things. So mastering simple things will allow you to master complex things, because generally the simple ideas are really the things that build the complex ideas. And so if you see, you know, if I put in a noise component to modulate this image here, I know a certain thing about that. That's a noise component modulating an image. So if I look into some trees that I've done, I can go, there's a noise component above that. I know that that's what I'm doing. It's modulating the space. You know, noise components can sit in other places as well, as I showed you with that circle before, but you can have a noise component actually modulating the color space as well. There's all kinds of, so if I was to see that in a system, I'm thinking, I'm using this noise component for some reason to modulate the color space of an image. I just know by looking at it that that's what I was doing. But doesn't mean that I can immediately understand every system, because they get far more complex than what you're seeing there.
Do you make use of the naming function for compile?
All the time.
You do, yeah.
Yep, yep. I name all of my compiled trees because if I get a long way down a path, I'll never understand what something's doing. Particularly when you've got, like, you know, lots of embedded compiled trees. You know, some of my systems are so complex that I don't even understand from the top tree what's in. If I didn't have them named, I wouldn't have a clue where things were. And if you're trying to build objects, for instance, in Voyager, where you're using the 3D shape transforms and stuff, and you have like 20 or 30 objects all working together with one another, you must name them, because you won't even know what you're looking at. And that becomes very important with DF modeling, because you're always looking at a flat space. It's not quite the same as modeling in a 3D app, standard 3D app. So you've got to really keep track of what things are doing what. Anything else for now, or shall we reconvene for the next one?
I think we've got a lot to digest, and let you go into your day and wrap things up. Thank you so much, Peter, for giving this series of courses, and look forward to continuing to have my mind blown next week.
I hope that was of some interest. I know it's all a bit dry at the moment. We'll get into fun stuff eventually.
Nice.
Good.
Thank you for attending, Steve, Andy.
Yeah, thanks, Steve and Andy. Nice to virtually meet you in movement. Okay, I'll see you again. See you again next week, and we'll look at some of those more complex tiles that show you how to make 3D objects in Voyager.
Awesome.
Good.
Cheers, everyone.